Okay, so I was talking about successes in image, speech, pattern recognition, even natural language processing and so on. So one interesting thing here is about sequences, right? So I'll talk about sequences now. Now sequences are everywhere when you're dealing with data. So you have time series, which is like say the stock market trends or any other kind of a series, time series. Then you have speech, which is again a series of phonemes, or you can have music, you have text, which is a series of words. You could even have videos, which are a series of images, right? One frame, each frame can be considered to be an image and so on, right? So in speech data, one peculiar characteristic of speech data is that every unit in the sequence interacts with other units, right? So words on their own may not mean much, but when you put them together into a sentence, they all interact with each other and give meaning to the sentence, right? And the same can be said about music or speech or any kind of sequence data, right? So all these elements of the sequence actually interact with each other. So there was a need for models to capture this interaction, and this is very important for natural language processing, because in natural language processing you deal with sequence of words, or all your text is, or sentences or documents are all sequences of words, right? So that is very important, and the same in the case of speech also. So if you take up any deep learning paper nowadays, it's very likely that you will come across the term recurrent neural network or LSTMs, which are long short term memory cells and so on, right? So this is also something which was proposed way back in 1986, right? So a recurrent neural network is something which allows you to capture the interactions between the elements of your sequence. I said at a very layman level, but of course we are going to see this in much more detail in the course, and this was also not something new, even though you hear about it a lot in the past 3 to 4 years. The first recurrent neural network, and what you see here is exactly very similar to what we are going to cover in the course, was proposed way back in by Jordan in 1986, and its variant was proposed by Ellman in 1990. Right? So this is again not a very new idea. This has existed for some time, but now there are various factors because of which it has been possible to now start using them for a lot of practical applications. As I said, one, you have a lot of compute time, the other, you have a lot of data, and the third is now the training has stabilized a lot because of these advances which I was talking about in terms of better optimization algorithms, better regularization, better weight initializations and so on. So it's become very easy to train these networks for real world problems at a large scale, right? So that's why they have become very popular and you hear about them on a regular basis. But it's again something which was done way back. And in fact, so from 1991 to 1994, actually people are also looking at various problems with training neural networks and recurrent neural networks, and they saw that this problem, which is known as the exploding and the vanishing gradient problem, which is again something that we'll see in the course in reasonable detail. Because of this problem, it's very difficult to train recurrent neural networks for longer sequences, right? So if you have a very long sequence or a time series, you cannot really train a recurrent neural network to learn something from that. And to overcome these problems, around 1997, long short-term memory cells were proposed, and this is again something that we'll cover in the course. And this is now almost the de facto standard used for training a lot of NLP work. LSTMs are used as one of the building blocks, and another variants of LSTMs which are known as gated recurrent units and some other variants. So this is also not something new, even though they have become very popular nowadays. Like almost any article that you pick about would talk about, any article on deep learning that you pick about would talk about recurrent neural networks or LSTMs or gated recurrent units. This is not something which is new. LSTMs had come way back in 1997, but again due to various compute and other issues which I said at that time, it was not so easy to use them. But by 2014, because of these parallel progresses which I mentioned, in terms of optimization, regularization and so on, people are now able to use RNN's LSTMs for large scale sequence to sequence problems, and in particular a very important discovery at this time, or very important model which was proposed at this time, which is the attention mechanism, which is used in a lot of deep neural networks nowadays, which enabled to deal with a lot of sequence prediction problems, or for example translation, where you have given one sequence in one language and you want to generate the equivalent sequence in another language. So this is known as a sequence to sequence translation problem. So for that, people proposed a sequence to sequence attention network, and this was one of the key discoveries which then led to a lot of adaptation of or rather adoption of deep neural networks for NLP, and a lot of research in NLP happened which was then driven by deep neural networks. Right? So, a lot of existing algorithms which are non-neural network based algorithms which are traditionally used for NLP were slowly replaced by these deep neural network based algorithms. Okay? And again, this idea of attention itself is something that was explored earlier also, somewhere around 1991 or so, and it was something known as reinforcement learning was used for learning this attention mechanism. And what attention basically tells you is that if you have a large sequence and if you want to do something with this sequence, what are the important entities of this sequence or elements of this sequence that you need to focus on, right? So, this is again something that we will look at in detail in the course.